10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Hello and Assalamu alaikum. My name is Wan Ahmad Shakir bin Wan Ahmad Salahuddin. My metric number is B0919100158 and I am from class BMMH S1/1. So, this is our group formal poster for the project Torsional Loading Evaluation of Doorknob in A3 size. As can we see, in our poster, we have provided some content such as introduction, actual project, discussion or analysis, FBD with all the forces, EOE, and close with some conclusion. In our presentation today, we will describe and share with all of you each content that have in our poster starting from the introduction until the conclusion. Introduction. In the field of solid mechanics, torsion is the twisting of an object due to an applied torque. Torque is a moment that twists a structure. Unlike axial loads, which produce a uniform or average stress over the cross-section of the object, a torque creates a distribution of stress over the cross-section. Torsion is expressed in either the Pascal and as a unit for newtons per square meter or in pounds per square inch, while torque is expressed in newton meter or foot-pound. Our objective in this mini project is first to observe the torsional loading of the doorknob, second to determine the free body diagram from the original structure, third to develop equation of equilibrium to show the forces act on the structure, fourth to determine the torsional force that will fail the structure of the doorknob, and finally our objective is to find the factor of safety in the doorknob. Structure. This is our actual structure for this project. Our material properties of structure is we use material 304 stainless steel. Our yield strength is 215 megapascal. Our Young modulus is 190 gigapascal. Shear modulus 74 gigapascal. And our ultimate tensile strength is 505 megapascal.
Hello, my name is Muhammad Hazim bin Ahmad Zulkafli and my matrix number is B0919103108. Today I would like to present about the free body diagram of our project. As we can see on the slide, we assume the force at our project is 200 Newton and the force goes clockwise. As we know, if the force going clockwise, the torsion will go counterclockwise, and the radius of our project is 0.02 meter. Next, for our equation of equilibrium or EOE, we can find the total moment of the structure. For our project, we assume the moment is positive if it goes clockwise, and the force we divide into two, which is left and right. After that, we insert the formula, which is force time length minus torque equal to 0, and we get our force after we separate, divide into 2, 100 Newton times 0.02 meter plus 100 Newton times 0.02 meter minus T. After we calculate, and then we get T equal to 4 Newton meter. After that, we can determine the maximum shear stress of the structure. As we know, the diameter of the structure is 0.04 and the radius is 0.02 meter. We must first calculate the polar moment of inertia to find the maximum shear stress. And for the polar moment, we use the formula of J equals to pi divided by 2 times C power of 4. After we substitute the value into the formula, we get pi divided by 2 times 0.02 power of 4, and the answer is 2.513 times 10 power of negative 7. After that, we use the formula of maximum shear stress, which is torque times radius divided by J, polar moment, and then we substitute the value. We get 4 times 0.02 divided by 2.513 times 10 power of negative 7, and we get the maximum shear stress equals to 0.318 megapascal. For the factor of safety, FOS, we use the formula of maximum shear stress divided by allowable stress. We must first determine the allowable stress by using the formula of F per A. As we know, our force in this project is equals to 200 Newton, and the area, we use the formula of pi times R power of 2, and we get the area equals to 1.257 times 10 power of negative 3 meter square. And then we use the formula of allowable stress to get the answer, and we substitute the value of force and the area, and we get the allowable stress equals to 0.159 megapascal. After that, we can determine the factor of safety by substitute the value of maximum shear stress and allowable stress, and we get the factor of safety equals to 2. Finally, based on the factor of safety of our structure, which is equals to 2, we assume that our project's application is for use with ordinary materials where loading and environmental conditions are not severe. That's all from me. Next, I will pass to my friend to continue the next slide. Thank you.
Hi, good morning and Assalamualaikum. My name is Muhammad Shazwan Zulhimi bin Muhammad Qasim, and today I will present about the discussion. A moment of a force or a torque is measured of a force tendency to cause a body to rotate, The moment depends on both of the force and on the position at which the force acts. Where the force of magnitude F acts as a perpendicular distance d from the point of rotation. The magnitude of the torque is T equals to force times with distance. The SI unit of torque is a Newton meter, and an unbalanced torque on the doorknob will cause it to develop a rotational acceleration according to Newton's second law of rotation. In conclusion, in this experiment, the concept of torque is introduced from Newton's second law. A force is applied an object gives acceleration for the object to move in translation. But in rotational motion, an object is said to be in rotation other than translation due to the pivot point, which is known as the torque. It is also a measure of force, but in rotational motion, a torque produces angular velocity, and change in angular velocity results in angular acceleration. Next, the student have deeper understanding in how the torque is produced and how to calculate the torque, how to measure the torque, and solving a torque problem. That's all for me. Thank you. This is the poster that we have created based on our project. It consists of introduction, discussion or analysis, the actual project of the picture, and we have the calculation for our project, which consists of the free body diagram, the EOE, the tensional shear stress, the polar moment of inertia, and the factor of safety. And lastly, we have our conclusion. So I would like to say thank you for listening to our presentation and have a good day.